Welcome to David Alexander Maths Tuition. This is Chapter 1E on Surds. So again, this is a topic you would have done at GCSE. So here are some of the rules. You need to remember that root 5 times root 3, that is the same as the square root of 5 times by 3. So that is root 15. Easy peasy. When there's a number in front of the surd, let's deal with these first. 2 3s are 6. Root 7 times root 4 is root 28. Root 3 times root 3, it always annoys me when my students struggle with this and they go root 9 and then they forget to simplify it. Root 3 times root 3 is 3 because this is root 3 squared, and square rooting is the opposite of squaring, so they'll cancel out, just leaving you with a 3. Root 3 times root 3 is 3. Root 5 times root 5 is 5. Root 11 times root 11 is 11. Just remember that, easy. With division, this is similar. Root 30 divided by root 3 is root 30 divided by 3. That's the same thing. In other words, root 10. When there's a number in front, 10 divided by 2 is 5. Root 15 divided by root 3 is root 5. So that is 5 root 5. Okay, this is where it gets a little bit more challenging. Root 20. So what I need to do is write this as two surds, where one of them is a square number. So if you need to make a list of your square numbers, what is the biggest square number that can that 20 can be divided by? Well, the answer is 4. So that is the square root of 4 times the square root of 5. You could just write it root 4, root 5, and remember that the square root of 4 is 2, so 20 is 2 root 5. Useful thing to be able to do, although obviously in A-level you can use your calculator all the time, and if you just type root 20 into your calculator and press equals, it will turn it into 2 root 5. Root 75 is root what times root what. So a square number that goes into 75 is 25. I always think it's easier if you write the square number first, and that becomes 5 root 3. Root 32. So some people, it might not be obvious that it's root 16 times root 2. Some of you might think it's root 4 times root 8. But you're always after the biggest square number, so the square root of 16 is 4, so that is 4 root 2. 6 root 8, well, let's look at root 8 first of all. Root 8 is root 4 root 2, so 2 root 2, so 6 root 8 is 6 lots of 2 root 2, and 6 times 2 root 2 is 12 root 2. Root 8 being 2 root 2 is probably one of the ones that you just memorise from doing a lot of surds, hopefully. Okay, when we're adding surds, we can't simply, it's incorrect to say root 8 plus root 70 is the same as root 8 plus 72, which would be root 80. That's complete nonsense. We need to simplify it. Now, root 8 is 2 root 2. Now, presumably, this simplifies to a certain number of root 2's. In fact, it is root 36 root 2. In other words, 6 root 2. So we've got 2 root 2 plus 6 root 2, which is 8 root 2. 5 root 50, well, that is 5 root 25 root 2 plus 2 lots of root 16 root 2. So that's 5 times 5 root 2, so that is 25 root 2. And root 16 is 4, so that's 2 times 4, which is 8 root 2. And 25 plus 8, that is 33 root 2. Expanding brackets in the same way that hopefully you can do, say, 3x plus 2 to get 3x plus 6. There's no reason why you should struggle with this. Root 7 times root 3 is root 21. Root 7 times 4 is 4 root 7. Double brackets, let's do FOIL, or as I do it slightly different order. It doesn't really matter the order. 2 times root 7, that is 7 root 2. Always remember to put the rational number first. In the insides, that's plus 35. On the outside, negative root 5 times root 2, so that's minus root 10. And 5 times minus 5 root 5 is minus 5 root 5. Can this one be cleaned up in any way? No, it can't. Okay, so this is an interesting one here. Well, it's not that interesting, I guess, but it's a useful one. Root 3, we've got identical brackets. The only thing that is different is one is plus, one is minus. So what that means is we don't need to bother with the insides and the outsides because they'll cancel each other out. So let's just do the first and last. Root 3 times root 3 is 3. Positive 1 times negative 1 is negative 1. and that is 2. So whenever you've got a bracket where it's with a surd plus a rational number and a surd minus a rational number, you'll end up that the surds vanish. And this is a useful thing when we're rationalising denominators later on. 4 plus root 5 squared is not 16 plus 5. It is 4 plus root 5 multiplied by another 4 plus root 5. So let's expand it as in the same order I normally do. So 16 plus 4 root 5 in the inside plus 4 root 5 on the outside plus root 5 times root 5, which is 5. 16 plus 5 is 21, and 4 root 5 plus 4 root 5 is 8 root 5. There we go.